Carlos González Alfaro.
Mariana Alcázar.
Melissa García. Melody Scarlett.
Now for the flowchart, we're going to start reading the problem. Do the research. In order to solve the problem, we have two formulas. So first, we have to find the variables based on the given problem. Until we have the variables, now we're going to describe the variables. Variables of the formula number 1 and then formula number 2. A is equal to future value or P is equal to principal investment amount. R is equal to annual interest rate. N is equal to number of time. T is equal to number of years. On both of the formulas, we have to substitute with the variables until we have the results. Now we can start graphing. Then when we analyze each graph. Then we conclude and it.
Our problem is problem number 1, and it states, a man invests initially $5,000 in an account that pays 8.5% per year. A. Find the amount after 3 years if the interest is compounded quarterly. Find the amount after 3 years if the interest is compounded continuously. C. Graph both models from question A and B, leaving T as a variable. D. Based on the graphs from the questions, C. Answer the following. What model, interest compounded quarterly or continuously, grows faster? E. Based on the graphs and using the tools from the graphing software, approximately how many years must pass so the amount is now 10,000 for both models?
Get sexy, girl, get sexy. Get sexy, girl, get sexy. Get sexy, girl, get sexy. Yeah. I heard that you sing go. Now you talking my lingo. Let's play casino. Bring 4 friends plus you. Bingo. You ain't nothing but a flirt. The way you bouncing in that shirt.
Now we have the problem. A man invests initially $5,000 in an account that pays 8.5 per year. Find the amount after 3 years if the interest is compound quarterly. Now we have our formula of compound interest per year. Now we have our values that P is 5,000, the amount that you invest, R is the rate, and is the percent of the year that you have to pay in the year, N is the times that you have to pay in the year, in this case is quarterly, and T is the time, it's 1 year, but in this case is 3 years. So now we solve 5,000 multiplied by 1 plus 0.085 over 4 elevated to 4 multiplied by 3. Now we elevate this to the 12th and we get 1.2870 and we multiply and we get that in the in 3 years he had an amount of 6,435.0. Find the amount after 3 years if compound is continuously. Now we have our formula of compound interest continuously. We have here our values that P is the amount that you invest, E is the natural number Euler, R is the rate, and T is the time. So now we solve 5,000 multiplied by E elevated to the 0.085 multiplied by 3. So now we solve. And we get 5,000 multiplied by 1.2904. Now we multiply this and we get that in 3 years he pays continuously and he get an inversion of 6,452. Now we have the graph of both models, and we can see that the formula of compound interest continuously grows faster because you have to pay all the time. And the formula of compound interest per year, only you have to pay the times that divide your pay, for example, quarterly or semestrally. Based on the graph and using the tools from graphing software, approximate how many years must pass, so the amount is now 10,000 for both models. And we can see in the graph that in the 9th year the amount passed the 10,000, and we can get it for logic. So now we can solve it. We have our amount and the years that are 9, and now we solve 4 multiplied by 9, 36, and we here get 1.02125, and now we get that 2.131839, and we multiply, and we get that in 9 years the amount is 10,859.19, and in the continuously it's the same 9 years. And now we solve 0.885 multiplied by 9, it's 0.75, and we elevate Euler by 0.75, and we get 2.1489, and we multiply by 5,000 and we get 10,744.97.
Applications in the real life. We can also apply the logarithms and the exponential function in everyday life when we make an investment in a bank on a new project involving economy and a lot of money.
better and we can see it in an everyday life. The most difficult part of the project was the part when we had to investigate theory and the procedure of a mathematical model to solve the problem.